I will speak in English because apparently this is recorded. This is the picture that best describes what kind of challenges I'm dealing on a daily basis. I hope I'm not the only one, but if any one of you actually is lucky enough to use only one tool or service from each of these boxes, please reach me out after this conversation. I'll buy you a beer. Like that was not enough, introducing the serverless landscape, right, which was invented by AWS and was joined by other major providers like Google Cloud and Microsoft Azure. Serverless is becoming like a parallel universe. So please raise your hands if this feels like too much to handle. Yeah, all right, that's good. I'm in the right room. So my name is Eugene Istrati. I'm the CTO and technology partner of Mito Group. These are my credentials. I won't go into the details. But today I would like to discuss about how we felt overwhelmed with this constantly changing and constantly evolving services and tools for cloud and serverless, and what our team did in order to address some of these challenges. So the devil is in details, right? So let's face it, we as engineers, we have a lot of services and tools nowadays, right? This exponential growth of technology is presents not only problems, but they also present opportunities, right? So unfortunately, I cannot talk about the customers that we're working with, the Fortune 500 customers, but I would like to talk about some use cases and challenges that those customers had. Right? And something common that we are coming across is this open source tool called Terraform that is used for infrastructure as a code, right, in those organizations. And I heard a lot of engineers saying that they are not able to use Terraform for serverless, which I respectfully disagree, and that's why I'm here. I would like to convince you guys that you were able to use it. A smart guy once says that when something is important enough, you do it even if the odds are not in your favor. And the history shows that this guy was right. And that's why we're also trying to do something that we believe in this one, and we'll get it through. So after a short description of the problem that we are dealing with and a short description of the approach that we are taking, I'd like to present to make sure that we are on the same page, right? We have the same context. So I'll talk next on what is the infrastructure as a service and what is the spectrum, what is DevOps spectrum, and last but not the least, what are the scopes and boundaries. So first, infrastructure as a service spreads across on-premises, co-location, hosting, infrastructure as a service, platform as a service, software as a service, right? As you can see, more or less the services are the same, right, or categories of services. But what's different is who is managing those services. Are you as a customer managing them, or a third party is doing it on your behalf? Now, I came across several definitions of what serverless means, but I like this one the best. Adrian Cockcroft, he's a former chief architect of Netflix. He's now VP at AWS. He said that if your platform as a service can efficiently start instances in 20 milliseconds and run for at least half a second, then go ahead and call it serverless. So in that context, everything else except software as a service and platform as a service is not in scope for serverless. Okay. Now, second, the DevOps spectrum includes everything between agile development, continuous integration, continuous delivery, continuous deployment. So that means that those are not optional, right? Those are required in order to embrace the full capabilities and the full benefits that DevOps provides. Right? And last but not the least, so if I would go back to the DevOps spectrum and mark the development and deployment services mark as A, configuration management and provisioning mark as B, orchestration and scaling mark as C, Terraform is B, but Terraform for serverless is a combination of A plus B plus C. Right. So now that we have the right context here, oh, choo. Sorry about that. Now that we have the right context, I'll go next into best practices and the lessons that we learned, right? So the first lesson that I want to talk about is the microservices architecture. Although it's a common pattern that is now pretty adopted by engineers, I still come across organizations that they are not using that, they are not embracing this, right? So the goal is to aim one-to-one relationship between your serverless resource and the Terraform configuration. So for example, actually heads up, instead of these best practices that I'll be talking about, they are not focused on, it doesn't mean that something is wrong, right? It means that it can be done better. So like, for example, in this case, instead of putting 4 or 5 resources in the same configuration file, right, you would actually break it down into different configuration files and use them as separate components, right? So the second one, once you have those components set it up, you can pass different values using Terraform remote state. So instead of hard coding, like in this case, we have the resource that it's called the role name. Instead of hard coding into different Terraform components, you would actually go back, create one service, define the component in one service, and they use in another service as a reference to the remote state, right? Now the third one is avoid using local provisioners and external data. So that's in our experience, we had a lot of difficulties when something goes wrong, right? So instead, you can use Terraform orchestration tools like TerraGrant or Astro or TerraHub, and you can put them as a hooks that tries before or after your Terraform execution, right? So for example, in this case, we're trying to avoid something like this by all costs, where you have an external data that triggers an Node.js file. We do like this. You define your resource, but then in an external configuration, in an external Terraform orchestration, you just say what you want to be done. And it says that before doing Terraform apply, execute that script, right? Now, next, so Terraform supports out of the box parallelism, right? So you would like to parallelize all of your executions, right? But on the other hand, because you have dependencies like in every code, you want to run some components first, other components second. So Terraform doesn't work that across different configuration, right? So you need to either specify this kind of parallelism to increase it, or you need to specify different targets, which is, again, it's another bad practice. We are using this TerraHub apply resource that spins up, in this example, it's like 8 different configurations that are not dependent on each other. It spins up them in parallel. So best practice number 5 is now, because you have a lot of Terraform code, right? You would like to optimize how you run this automated workflows, right? And what we do, we're using it with Git diff. So for example, instead of running 10 different components every time when you have one change to one or two components, we're using this approach that you say git diff, you specify what are the branches in your Git repository, and it breaks it down only to the changes that you've done to the specific components, right? So in this case, it's like an 80% improvement already, right? You don't need to do everything, the other 8. Moving on to the next one, logically separate the environments, right? It's even like on the Terraform website, it says that you can just copy paste the configurations for each of the environments, and that's how you do the separation, right? So instead of having, I know it's a little bit blurry, but those are the 4 different environments, and this is exactly the same code, just with different values. We're using Terraform workspace in order to define which environment corresponds to, which Terraform configuration corresponds to my logical environment, right? If it's a dev environment or stage or production, right? And we have an internal, we agree that everything that is dev goes default, so we don't need to specify the environments. Last, or the 7th best practice is overwrite your environment-specific variables. Right? So, for example, like in this case, where you have account ID, region, actually, sorry, not account ID, but region and bucket, they're kind of the same, but the account IDs are different. And instead of hard coding them into different ones, you're defining the ones that you are using for your development environment, all of the environments. And then when you have to use for example, for your staging, you just the values that you need to override, you put them in TFRs, right? And this is a native Terraform feature. This is the link where you can read about how to use the variable precedence. All right. Last but not the least, well, either get comfortable with a lot of Terraform code, or you can use some orchestration and management tools like TerraHub CLI, which, so for example, in our use case, we have right now more than 100 Terraform components to build out a pretty decent sized serverless application. So we were able to reduce the amount of code from almost 34,000 lines down to a little bit less, 20,000 lines of code. So that's a 45% improvement in the code. I'll take it. Now, just to summarize, right? Adopt microservices, pass variables between configurations, right? Using remote state. Avoid local provisioners and external data. Execute in parallel, right? Don't forget about dependencies. Optimize using git diff, right? Locally separate environments with Terraform workspace. Override specific environments using variable precedence, and get comfortable with lots of Terraform, or don't. So everything that all of these best practices, and there are many more, I just don't have time to talk about all of them. We created this open source tool that we're calling TerraHub CLI. And just go check it out if you guys like it. Help us out, put a GitHub star on it. So I will jump into the demo. And in this demo, you can see in the README all the details, how that gets created, how it gets executed, how it gets distributed the execution of Terraform commands, right? And today, if I will have time, I would like to go through 4 different steps. The first step will be running Terraform with local state, right? So it locally stores all the TF files, all the results of my environment. Then I'll run the Terraform in an CI/CD pipeline, which just using Jenkins. And then I will try to open just a pull request in GitHub and just show you that I technically don't do anything, but everything magically happens on behind the scenes. And if you guys want to see what is means behind the scenes, I'll show you that. All right? Okay. So let's switch to our presentation. Okay. I had this problem before. Let's do like this. Okay. All right. So can you guys hear in the back? Can you see? All right. So the first thing that I would like to show you is, this is the GitHub repository that I was talking about. Right? I intentionally put it as separate that I'll be showing you the UI from time to time. The idea here is that it actually describes how we automated Terraform executions for an existing code, right? It also tells you how to create IAM roles. Like it tells you everything from the beginning. I'll skip all of these steps. I'll just jump directly to the automation part. And the automation part is is this one. Okay. So let's give it a try. So what's important to point out here is that this is a public repository, right? And I will open one file. I thought it's too quiet. I'll open one file and I'll show you I have like account ID, which in theory, that's something that is supposed to be private, okay? So that's one of the commands that is part of the TerraHub CLI that we've built, is that on the fly during my execution, I will be able to change those variables, right? So I don't need to manually do all these things. Okay, and the way to do that, again, if I go back, it's also documented here. This is the account ID. You can hard code your value, right? Or I'm using AWS CLI to obtain the account ID directly from my account. Okay? So that's what I will do here. My first step is I'm running a command that changes the account ID. And okay, and it's done. And now I'm able to run the TerraHub run apply auto approve. Okay? So while it's running, I want you to know that what's happening right now, that it runs 7 different resources, launches 7 different resources in AWS, right? So it creates an IAM role, because that's what I need for Lambda. It creates a VPC, subnets, and security groups. So those are the 4 dependencies for my Lambda. Then once I create my Lambda, right, I then create an API gateway, and I deploy my API gateway with reference to the Lambda, right? So API gateway is dependent on Lambda, and then the stage deployment is dependent on the API gateway REST API, right? So right now it's the final step. It says API gateway deployment, and it's done, right? So I can take this one, can get this URL, Ta-da! All right. Okay, so it worked. Now, this was the first step. Now I need to go to the second step. But I cannot just go to the second step, because if I run exactly the same code in the CI, it will identify that the Lambda is already there, API gateway is already there, IAM roles are already there, and I'll get an error, right? So what I need to do, I need to destroy this environment so that I can create it from scratch again. So I'm going back actually to exactly the same command and just add -- destroy. These use cases with destroy being at the end of the execution are important specifically if you're doing QA, right? If you're testing your code. Instead of waiting for each time to do something and then go back, do manual change, you can also run it in automation. And at the end of just, for me, is important when I develop Terraform code is to see that it's spinning up the infrastructure. And if it's spinning up, then I can delete it right away. I don't need that infrastructure. I need to know that the code is working, right? Okay. So while this cleaning up the code, I'll go to the second step. And the second step is, so I created a Jenkins job. It's a little bit, so long story short, the code that you see there in Jenkins job is exactly the same code that is in repository in the bin file, and you'll have deploy-jenkins. So you guys can take a look. So the one thing that I need to do is make here the change. And haha. Thank you, Jenkins. Oh, 1 second. So we're trying to be kind of secure, and everything is behind an SSO. And the SSO is having 1 hour expiration timeout. Right? Okay, so I changed this one. I'm running the build. And I just open the console, and you'll see it's actually happening exactly the same thing that happened before, with a lot of these done. That's actually changing the configuration from the local TF store, the local TF state, into a remote TF state, right? So now, because I'm running in Jenkins, it's a distributed system. I'm not able to rely on my local storage. I need to store all of my Terraform states somewhere else. And we're using S3 for that. And that was the command that you've seen done. It's actually changing from the local storage to the S3, right? And making it remote storage. All right. So again, it does the same automation. The benefit of this one is that it's just an orchestration layer on top of Terraform. It doesn't change your Terraform. It just runs the sequence of commands: Terraform init, Terraform workspace, Terraform plan, Terraform apply, and if you enable it, also Terraform destroy. Okay? All right, so right now, it does the Lambda, it creates the Lambda. And you can see in the logs, it's actually say Terraform apply, Terraform plan, and it shows you all the details that you need for this application, right? Okay. All right. So while this is finishing up, what you see in the right is you as a developer, or me as a developer, I'm comfortable with what I see on the left, right? But we're working with a lot of enterprise customers that they are not comfortable with what's in the left. And they need something like what's in the right. So I'll talk next to that. So let me go again, open this link. All right. No? Okay, it's working. All right. So the same story as before. Actually, it's not the same story. But if I want to show you from the beginning that I open the pull request and it does exactly the same, I need to clean up my environment, right? And that's why I have over there having something like the same command, just with destroy at the end, right? So I'm going back to my Jenkins, running. It will clean up my environment, okay? So now I'm done with my second step, right? Or second step of the demo. I run on local, I run in a CI, right? Now I want to, it's still using a CI service, but it's all native in AWS. So it means that I'm going to my code management system, and right now I'm using GitHub. I'm open pull request, right? On the pull request, GitHub triggers API gateway. The API gateway triggers Lambda, that is the orchestrator, right? And the orchestration, it works with code pipeline and code build from AWS in order to run on this all this automation, right? In order to be able to handle the distributed aspects of the automation, as well as in order to be able to handle the concurrency, right? If I run my automation on exactly the same repository, I definitely don't want two PRs to generate me two different runs and mess up everything that I've done, right? I want it to be sequential. Run the first thing. When you're done that, you can run the second thing, right? So the idea that we're trying to build out here, and it's evolving work in progress, is because this environment, these enterprise customers, they need control over what's happening. And what we are giving them is basically, first, is the native capabilities in the cloud. If you're using AWS, it uses all the native capabilities of the AWS, right? If you're using other cloud providers, again, it uses those native capabilities of other cloud providers. For example, Google just launched the Cloud Run service, and we're integrating with Cloud Run in order to be able to do that on the Google Cloud. Okay? All right. Come on, dude. Okay, it's almost there. So it cleans up now the last service, cleans up Lambda. All right, we're almost there. Okay, so I'll start preparing. So this is GitHub. All the code is openly available, right? I have two branches. One is master that does my production deployments. Another one is dev, which does my development deployments, right? And I connected the Terraform workspaces to my branches naming in GitHub, right? So I can have dev is my development environment, test is my testing environment, stage is my pre-production or staging environment, and master is my production environment. And when I want to deploy something in one of these environments, that's what I will be showing you guys next, right? So, demo, Cluj. 1 second. Let me. Okay, this is done. Now, let's do it. So you can see here, it shows you a check that currently what's happening is my automated deployment started working. Me as a developer, that's all that I want. I don't need anything else, right? But I guess, I assume you guys want to see more than that, right? So let me go over here. Let me pull code build. And let me show you what's happening right now. You see, it's in progress. What's happening in code build. Come on. All right. So you can see, again, on the left is those things that engineers like, but non-technical people, they want to stay away from it. All right. So, and that's why I'm coming here and wanted to show you guys. Wait, we have an error. And by the way, this is an expected issue, right? So the backstory is we wrote terrible code, and then we like the output because I'll go back to my GitHub, and it helps me to show you an error which was generated by a developer, not by the service, right? So in this case, what's happening? We are trying to read the remote state of a file that doesn't exist, right? The infrastructure was not set it up. There is no remote state for Lambda, for example. And it tries to read, API Gateways tries to read from Lambda, and it doesn't find the file, and throws an error. So if I open up, I see exactly the same log that I saw on the code build side, right? And this is the error. Right? It says no REST API. Okay, so I'll go back. One thing that I forgot to mention and I just realized is every time when we open a pull request, it runs the workflow, the automated workflow is init, workspace, plan. It doesn't do apply. Because I want, in my automation, I want to see that everything that I've built, like in this example, that goes through the plan, and I can see the plan, and I can say, okay, this is the plan that I want. Right? And if I like it, I will send an approve message, which will basically also does the init, workspace, plan, and apply. Okay? So that's what's happening over here. It just ran the plan, and the plan failed. But let's assume we are good developers and we build really good code and it went through. So I'll do right now approve. Okay? It goes back. It starts again, this check. You see it's over here. I apologize. I realize it's not that clear at the back. But you anytime can go back here and open the pull requests and see what happened, all right? Or take a video and zoom in. Okay, so let's go back to this guy. So I'm going back. Okay, it's in progress. Tail log. Okay, right? So now everything runs smoothly, and hopefully it will show a successful result. Actually, let me refresh here on the right, because I have a feeling because I disconnected, that's why it's not showing anything on the right in real time. Come on. All right. There you go. Okay. So I told you that the non-technical or people who are responsible of operations and are responsible to see the high level, that's what we're trying to show them in real time, showing you what's happening with your executions, right? You see the workflow, you see the number of components, you see the changes that we've done, and when something is successful, in theory, you see on the right side. On the right side, it says that everything was successful, on the left side, you have here this done, right? Okay. So I'll go back to my GitHub. And now it waits to get all the results from the code pipeline. When code pipeline finishes the execution, it sends us back the log. And based on the log, we are able to identify and we're able to post another message into your pull request. Okay? So let's, oh, it's done. Okay? So you see, this check was successful, right? You see the log message. It says it was successful. You can also open up the log and see everything in the log. And right now, it's one of our features that we would like to add to the capability that you see on the right. Instead of opening up these logs, maybe you don't want to expose those logs externally, right? We'll be opening up and putting links to the tool in the right. So you can open up in this real-time dashboard, and you can see all the details, what's happening right now in this moment with your infrastructure, right? You can tail those logs, as well as you can go back in time. You see historical executions, right? And okay, so that was kind of part of my demo. I have another beta feature that we are right now working on it, and I still have 4 minutes, so I'm debating if I should show it or not, because I'm almost positive that it will be not successful. So yeah, I'll not show it.
Actually, I have a few questions.
Go ahead. Shoot.
One of them, and I'm really slow, so bear with me here.
No problem.
As a developer, why did I run 2 checks and one passed and one failed without me changing anything?
Why did you run?
So I ran 2 checks in a pull request, like
Yes.
2, and the first one failed. I didn't change anything. I reran it, and it passed.
So the code that we wrote, the Terraform code that we wrote, right? Right now, it doesn't consider the fact that if the infrastructure doesn't exist, or some resources they don't exist, you don't have the Terraform states files, right? Then when you refer the TF states file, remote files from another Terraform code, right? It doesn't find that TF state, and it throws an error. And that's the behavior of Terraform 0.11. With Terraform 0.12, they changed that, and it will not throw an error. It will basically tell you you're missing the file, and you as a developer will be able to say, if I'm missing the file, I want it to fail, so I want an error. If I'm missing the file, no problem, keep going. Right?
Okay, that makes sense. That makes sense now. Thank you. So who else has any questions? Don't be shy. Questions? Yes.
Hi.
I'm sorry. I forgot to turn it on.
No. Hi, can you hear me? Yes.
Yeah.
So I apologize. I came a little bit late, so if you covered it, maybe I'm redundant. But do you have any data quality check applications of this? In
So
terms of
data
like
quality
real
check.
time looking at the data, or
Yes.
automating it?
So one of the things that we've introduced into the tool is that we're trying to analyze everything that we are receiving from TF states, and we're trying to show them into the UI. So first of all, you can see what's happening, right? You can see the infrastructure that is created, and second of all, and that's pretty common use case. We worked with customers. We set it up this automation for them, right? We didn't write the Terraform. We just set it up the automation. And then they come back and they make some changes manually. And so that features, or that capability is called infrastructure drifting, because whatever you have in the TF states files is completely different than what you have in your actual AWS accounts, right? So back to your question with data quality, yes, that's part of the features that we are building out in the tool in order to be able to show the quality of your code, the quality of the data that gets generated by Terraform, and to be able to prevent some changes to infrastructure that was not desired by developer or by whoever created that Terraform code.